Hey there, everybody. I got a good report from the sub the last time, so thank you for doing what you needed to do. I will be back again. I will be here for student-led conferences, and I will be back the following Monday, but just keep up the good work. I know that you are going to do well. Here is the preparation for the quiz, the test. And I wanted to take a moment to go over each of these problems with you so that you are prepared to take this test. Now, by this point in the class, my hope is that you've had a chance to do these problems on the board. And if not, then hopefully you can take a moment to do them with us so that you get ready. The test takes about 45 minutes to do. There are only 10 questions, and these are very similar to the questions that you have. The test covers addition, subtraction, multiplication, and division of polynomials, and then some vocabulary. So let's get started on this first one. I notice as I look at this that this is an addition problem. And with addition, if I were to make a note card, again, on this test you may use a note card, but you can totally use a note card. So this is an addition problem. So for an addition problem, and here let me take a moment to zoom into this one so that it occupies our whole screen. For an addition problem, the number one thing that I want to be sure that I'm remembering is that all it is combine like terms. All it is combine and I don't need to worry too much about anything else. So as I approach this problem, I'm going to cross things out as we go. So I notice that I have a 2x to the third power, and there's nothing else in here that has a 2x to the third power. So I'm going to write 2x to the third power, and then that's gone. And then I'm going to look for the next highest powered thing, which looks like this x squared. So I'm going to write, and I don't see anything else in here that has an x squared, so my next term is that 8x squared. So plus, it's a positive 8x squared. And then I'm looking for the next highest term, which is my x's. So I've got negative 4x and negative 2x, and negative 4 minus 2 is negative 6x, and those get canceled out. Oops, I forgot to cancel that one out before. And last but not least is my single terms. So I've got my 5 plus 4. 5 plus 4 is 9. This is my final answer. Some things that I hope that you are able to notice about this is that this is a third order polynomial. So here's some facts about this. This is a third order polynomial. Because the highest power is a 3. This also has, if I count them, 1, 2, 3, 4 terms. There are a total of 4 terms here. 4 terms. And I've got a bunch of coefficients. I've got a coefficient of 2. I've got a coefficient of 8. I've got a coefficient of negative 6. It's just the number in front of the variable. And then those are my 3 coefficients for this polynomial. So we're going to move on to the subtraction problem. So I've already identified that this is a subtraction problem. So if I were to write a note card, or on one of my 2 possible note cards that I can use, subtraction, I know that I first need to distribute the negative. Distribute the negative. Distribute the negative to everything in the parentheses. Now when I do that, that just means that everything gets the opposite sign. So I'm just changing the sign on everything. And then I need to combine like terms. So the first sequence is there's no negative that needs to be distributed, and so I can just take this. So I'm just going to rewrite 3x squared plus 4x minus 6. And then I'm going to start distributing. And I distribute that negative to everything in the parentheses behind it. So what was negative 5x, it changes the sign. So it's a positive 5x squared. It's a positive 3x because it's changing the sign, and a negative 8. All I'm doing is changing the sign. And now I get to combine like terms. So I've got my 3x squared, my 5x squared. That makes 8x squared. I have my 4x and my 3x. That makes me 7x. It's a positive 7x. And I've got my negative 6 and my negative 8. And that makes me negative 14. And this is my final answer. Again, this is a second order polynomial because the highest power is 2. There are 3 terms here, and the coefficient in front of this x squared term, the coefficient is just the 8, and the coefficient behind this term is just the 7. Okay, we're going to move on to the next idea. I'm going to move down to this one. So this is a multiplication problem, and with a multiplication problem, we need to use the tabular method. Multiplication problem. And I need to use the tabular method, which just means that I'm using the boxes to solve this problem. So I have 3 terms in the first polynomial, and then I have 2 terms in the next. So I need 3 by 2, so I'm going to go ahead and draw that. 3 and 2, I like to do it this way, but you could have done it the opposite way if you did. That's fine. So 3 by 2, and so my things that I'm multiplying go on the outside. So my x squared, my 5x, and my 2, and then x minus 3. So inside each box, this is the area where the side length is this. And so this is where I take the stuff on the side, my side lengths, and I multiply them to get what's on the inside. So x squared times x is x to the power of 3. 5x times x is 5x squared. 2 times x is 2x. Now to the next row. X squared times negative 3, negative 3x squared. 5x times negative 3, well, negative 3 times 5 is negative 15, and then x. And 2 times negative 3 is negative 6. Remember, we're multiplying. And here I know that because I have all of my place values for all of these polynomials that I'm multiplying, because I have all of the place values, it turns out that my diagonals are like terms. So I've got that, those 2 are like terms, and then the 15x and the 2x, those are like terms. And so I'm going to just draw arrows saying that these come out. So I'm going to combine like terms. So x to the power of 3, 5x squared minus 3x squared is a 2x squared. Negative 15x plus 2x is negative 13x, and then minus 6. So this would be my final answer. And this is a third order polynomial because the highest power is 3. And this first term has a coefficient of 1. Imagine that, because there's an invisible 1. So there's a coefficient of positive 1 in front of this. Coefficient of 2, coefficient of negative 13 for this polynomial. All right, last but not least is the division problem on the board. And I'm going to promote this, I'm going to promote using the reverse tabular method. And the first thing I want to do is remember how to do the boxes for these. So I want to, I wish I could turn this arrow around. But notice at the if you turn around at the bottom, if you look in this direction towards the whiteboard that's next to the screen here, you'll see that there is a way to predict the number of boxes that I need for this division problem. Excuse me. And what we're looking at is we're looking at the degree of each of the polynomials. So this is a fourth degree polynomial, and this is a first degree polynomial. And so I know that one of them is the bottom, the degree of the polynomial plus 1. So the degree is 1, so 1 plus 1 is 2. So I need 2 boxes for one side. And then the other thing that I need is I take the top, so 4, minus the bottom, 1. So that's 3 now. Plus 1 is back to 4. So I need 4 by 2. So I'm going to go ahead and draw a 4 by 2 boxes. 2, 3. And I'm going to put my x minus 3 on the outside here. And then in the diagonal goes the stuff from the top. So I've got my x to the 4th. I've got my negative x to the 3rd. I've got negative 6x squared, then negative 9x, and 27. Now, I always like to start in this box right here because if I have a remainder, then I don't need to worry so much about it. So I'm going to start there, and I'm going to start it in with a color. So I know that that's x to the 4th because it's the only thing in the diagonal, which means that on the top, what's on the top? X to the 3rd. X to the 3rd. And if I fill down, well, that's the funkiest 3 I've ever drawn. Let's rewrite that. X to the 3rd. So if I fill down, I get negative 3x. Now, what do I get up here? I have to consider this box plus this box equals that stuff. So what goes up here? That's got to be 2x squared. Oh my goodness, I forgot the 2x to the 3rd. Forgot the x to the 3rd. And so then I can fill in on the top. 2x squared times x gives me 2x to the 3rd. I fill down, so 2x squared times negative 3, negative 6x squared. If this box plus this box add to negative 6x squared, then this has got to be 0. Okay, so 0x squared, which makes up here 0x, which makes this 0x. Diagonals have to add up to negative 9, so this has got to be negative 9x, which makes this negative 9. Negative 9 times negative 3 is 27. I do not have a remainder. That's positive. And so my answer to this division problem is x to the 3rd plus 2x squared plus, oops, I can forget about that plus 0x and just say minus 9. So this would be my answer. All right, I want to take a moment, give you a chance to catch anything you didn't, and I know there will be one question where the division problem has a remainder, so we'll do one of those really quickly. If you don't know what to do or you were absent when we learned about remainders, I want you to go as far as you can and I'll grade what I can. But I do want you to be, I think that you should be able to do most of the division problem, even if there's a remainder. So here's the division problem I want us to try. If you would pause the video and try this really quickly, maybe pause it for 2 or 3 minutes to get started on this, and then go. I don't want to take too much of your quiz time because that's what you're going to do for the rest of the class. All right, hopefully at this point you've had an opportunity to do this division problem. Again, I'm going to promote the use of the reverse tabular method. So it turns out that this uses a 2 by 2, where x plus 2 is over here. And in this diagonal, I've got x squared, 5x, and 8. And I'm going to, all right, so I'm going to start with x squared. So something times x is x squared. That something's got to be x. X times 2 is 2x the diagonals must add up to 5, so this has got to be a 3x, which means that up top we've got a 3. And if I use multiplication to get this bottom box, 3 times 2 ends up being 6. Now, I realize that that does not make this, and so I need to go in and add an additional box, and this additional box is going to be my remainder. So I think something plus 6 is 8. Well, 2 plus 6 is 8. So I've got to fill that in with 2. So my remainder in this problem is 2. So how do I write that in my final answer? Well, this division problem is equivalent to x plus 3 with a remainder of 2, and it's a positive 2 dividing by the thing that I was dividing with. So it's 2 divided by x plus 2. X plus 2. And this is my final answer. It's a division problem. This is my remainder. It's very similar to division in general. The only difference is the remainder piece. So I think that you should be able to do something like this. If you want to do this with long division, go for it. I'm just not going to show it today to get you going on your quiz. All right, before we begin, I just want to be really clear that you may use 2 note cards and you may also use a calculator, but you may not use your phone. If you need a calculator, please help yourself to any of the calculators in the room. You know that the black box underneath the front desk has a lot of calculators that you can use, and the back of the room has those bright yellow calculators, and you are more than welcome to help yourself. If you don't have a note card, but you would like to use a note card, you can use something that's equivalent in size to 2 note cards, and that's about a size of a half a sheet of paper in size. My writing is not very good right now. Equivalent in size. So if you're using something equivalent in size to 2 3x5 note cards, I am going to collect, or I'm going to have the substitute collect these at the end when you're done. That's to ensure that I see what you're doing and that there's no cheating that's happening. So please be sure to turn those in at the end of your test when you're done. Your desk must be facing forward in order for you to receive a test. Your phone and music devices need to be away. If you're listening to music, you may listen to music, but your cell phone must be completely out of sight. I've asked the substitute to take notes about students who are not doing what they're supposed to be doing, meaning if there's a cell phone out, you will likely be written have that documented, and I want to make sure that you are aware that that's what I've asked her to do. Please only raise your hand if you have a question, and the substitute will come and collect your quiz when you are done, along with your note card. So be sure that you turn in your note card when you finish your test. After the quiz, there is a diamond problem worksheet that I want you to work on. We'll talk about a little bit more about this, or I'll have Ms. Johnson talk about that on Wednesday. Excuse me, the next time I see you, which will be I think she sees you next Tuesday. So next Tuesday she'll talk with you about the diamond problem when you're done. I will just turn to the next slide and probably pause the video on the next slide to know what you need to do when you're done, which is the diamond problem. Those are on half sheets, and you can keep them, and we'll talk about them the next time we have class together. Best of luck. I hope to see really good, successful tests, and I will see you at student-led conferences. Please come by and say hi. I really miss y'all, and I want to see you before the end of the year. Best of luck. Bye-bye.